Alright, so now I just want to briefly touch on subtraction of vectors, since I had done addition in the other video. Subtraction of vectors. Now it's very similar to addition. It's actually almost exactly what addition is. So really, before we understand what subtraction of vectors is, we have to understand what the negative of a vector is. So if we had a vector like this, for example, some vector like this, the negative of that vector, the negative of this vector, negative is exactly this vector but rotated in the 180-degree opposite direction. So this is negative b. Right, so if we had a vector like this and it was like a, negative a would be the same exact vector, just 180 degrees in the opposite direction. So really what we're talking about, if we subtract two vectors, hold on, I'm a little ahead of myself. When we subtract two vectors, let's say we're subtracting a and b, what we're really doing is we're adding one vector to the negative of the other vector. And this means that, for example, if b in our vector notation had this x component in the I direction and this component in the j direction, the negative b essentially means that these components are negated. That's all it means. It means that if this vector b were 2 in the x direction, had a magnitude of 2 in the x direction, and 3 in the y direction, then negative b would be negative 2 and negative 3. It would just be flipped around. And this, of course, influences the angle. This would create a... yeah, this would... would it influence the angle? No, it wouldn't, right? Because these would both be negative. But yeah. So, but it just influences the direction. It doesn't influence the angle. Sorry, because it's basically the same exact vector. The only thing that's different is the fact that it's just running along the opposite direction. It would have the same angle from a horizontal. Right? It would be the same exact angle on both of these. The only difference is the way that it's running. Maybe in this case it would be running northeast, and in this case it would be going southwest. And that's important too, actually. When you're defining the direction of an angle of a vector, you have to make sure that, because a lot of times, sometimes it's not typical that both of these will be positive. One might be negative and one might be positive. So you're going to have the arctangent of a negative number, and that's going to produce some sort of angle that will be in the other quadrants. So you have to make sure that when you specify direction, you're not only specifying the angle from the x direction, but you're also specifying in what actual direction it's going, like northwest. Like if it was going northwest, you'd have to say it's going northwest, or if it's going northeast, or if it's just going northeast, south, and west. So that's just a quick note. But in this case, you would do exactly what I did in the other video, except first you would change the vector that's being negated into this negative version. And then you would just find your new vector the same way. And that's basically the subtraction of vectors. Right, so in this case, if A was like this, and B was like this, C would look like that. But in this case, if we're adding A and negative B, which goes in this direction, C will go that way. It'll be a different C than this, because this would still be A, right? That's A. But then this B will now be going in the opposite direction. And therefore, it'll be this new C that's going in pretty much like a new direction. It would have a new direction. So that's basically the subtraction of vectors. It's not terribly different than addition. It's pretty much the same exact thing. But you have to make sure that you're respecting the notations. So I'll just actually real quick kind of show you, right, if we had A of x in the I direction plus A of y in the j direction, and negative B, negative bx in the I direction minus by in the j direction, then the sum of these, which is really the subtraction of A from positive B, or A plus negative B, would be ax minus bx in the I direction plus bx plus ay minus by in the j direction. This would be the vector c, right? So that's basically the only real difference